All right, it's our last day working with inverses and functions. What I want you to do right now, so I want you to write problem number 9 in your journal. I want you to write f of g of x is where you take g of x and you plug it into f of x. When you do this process, if it becomes just x, that means that these functions are inverse functions. Also, if you did the reverse, if you did g of f of x, which is taking f of x and plugging it into g of x, if that also just becomes the value of x, that also lets you know that they are inverse functions. Now, what is the line that inverse functions always reflect across? What do they always reflect across? Y equals x, right? So inverse functions always reflect across y equals x. So right now what we're going to do is we're going to do this one algebraically. That's the very first one that we're going to do. Show you how it works. And then we'll do this one right here as well. So we're going to do this step by step so you see how it's done. Alright, first one's first. Here we go. Number 1. We're going to do f of g of x. We're going to do that first. Now what's f of x just by itself? F of x is 2x plus 3. Right here, 2x plus, say, 3. But now we're going to do what? We're going to replace the x value right here with g of x. I'm going to open up a big old parentheses. And what am I going to put in the place of my x value? I'm going to take this function right here, which is x minus 3, all divided by 2, and I'm putting that in the place of x. All right, so what do you notice right here? We have 2 that's going to be what? Multiplied to all of this. Well, if there's a 2 right here in the numerator and there's a 2 in the denominator, technically, those right there would cancel each other out to a 1. And now you're left in parentheses with just an x minus a 3 plus a 3. So if you have x minus 3 plus 3, these are additive inverses. And what are you left with? You're just left with x. And that lets you know that f of g of x, that equals x, and that means they are indeed inverses. That's the very first one that we did. All right, so problem, first step, we did f of g of x, which means we took g of x and plugged it into f of x. So that one's done. Now what I'm going to do, you can do this in your journal. I'm going to draw a line here. You do number 2. Number 2 was g of f of x. You're going to test that. You can see if it equals just the value of x. So what is g of x just by itself? G of x just by itself is equal to what? X minus 3, all of this. So now we're going to take, what is g of f of x? That's not very good. There we go. Parentheses, minus 3, 2. We're going to highlight this area right here, which represents where I'm going to plug in f of x. Yada, yada, yada. What are we going to plug in here, Kaylee? What am I going to plug in right there? So I'm going to do. Very good. So now let's check. Let's see what we have here in the numerator. Okay. Got a 2, got a minus 3, and here we have a 2x plus a 3. What's going to happen to those guys right there? They cancel out. So now you have what? 2x over 2. What's 2 divided by 2? 1. So those end up canceling each other out. And now, once again, you're just left with x. So not only was f of g of x, but g of f of x also ended up equaling in x. So that also lets you know that, hey, these are inverses of each other. On problems 9 and 10, which we just did problem number 9, I just want to see your work. Like, how did you plug it in? All right, I want to see your algebraic work as you do. Okay? So on your paper, when you're doing this, if you want to, you can maybe make a little column. If you wanted to, you could say, all right, Mr. Mood, I'm going to make a little column for you. All right, and one of them, I'm going to do f of g of x, and the other one, I'm going to do g of f of x. So I can see you work both of them out. Okay. So I'm going to be evaluating how you plug something in. All right, here we go, everybody. Let's check this out. All right, so right now, what I'm going to do, I'm going to put equals in blue. I'm going to put an open parentheses. I'm going to square it. I'm going to divide that sucker by 2 and put a minus 6. And what am I going to put right in that parentheses, Jade?
Oh, you're going to put the
square root of?
2x.
All right, square root of 2x plus 12. 2x plus 12. Excellent, good job. Now, over here on this side, I'm going to put equals the square root 2. Going to open up parentheses. And at the end, I'm going to put a plus a 12. Now, Kaylee, what am I going to put in this parentheses?
You're going to put x squared over 2 minus 6.
I like it. So right now, you took one function and you put it in the other function. I like this table right here because you can kind of see the difference between the two functions. All right? Like the table. Should have done that the first time.
Yeah.
All right, well, okay. Now, what we're going to do first, here's the cool thing about square roots. Look at your graphing calculator real quick, all right? Go to, just look at your, I'm going to clear all this out. Look right here. You see x squared on your graphing calculator? Do you see that? What is above, right here in blue? Right there above the, it's the square. So there's the square root symbol right above where it says what? X squared. So you have the square root symbol right above on the calculator where it says x squared. These are what? Reverse operations. Which means if you square a square root, what's left here? Just the 2x plus 12. Very good. And that's all minus 2, minus 6. Now, so basically, to get rid of a radical, what do? You square it. Now, here we've got, sometimes students are like, well, what do I do with this? Do I do 2 into this, or do I do 2 into this? And I say yes. Because technically, 2x plus 12, you could rewrite as 2x over 2 plus 12 over 2. See how these have the same denominator? And if you were adding fractions together, the numerator would be 2x plus 12. Now, is 2 divisible by 2? And what are you left with? Is 12 divisible by 2? What are you left with? And then what do you have way over here? What do you have? You have a minus a 6. So what happens? We get just what? Just get x. Now what does that tell you? That tells you that these inverses are depths, right? These functions are inverses of each other. Okay? Now this one, oh, one second. Alright, let's take a look at this one right here. Focus. First thing I'm going to do is I'm going to distribute the 2 to both numbers inside of this radical. So I would get a 2 and an x squared over 2 minus 2 times 6 is 12. And then over here, what do we have sitting on the outside of the parentheses? Just a what? Just a plus 12. I'll change that to green. Aha! So, 2 divided by 2 is what? 1. So we have a 1 what? We have a 1 x squared minus a 12 plus a 12. What happens to those? They cancel out. So don't forget, this is all underneath the what? It's all underneath a radical. And what is the square root of x squared? It's x. Now you could say plus or minus x, but we're going to say this right here gives the value of x. And it says, by the way, at the very beginning, it says where x is what? Where x is greater than or equal to 0. So this value has to be what? It has to be greater than or equal to 0 for this to work. Okay. Now, let's say you do a g of f of x or an f of g of x, and you don't get x. What does that tell you about those two functions? They are not inverses. Only if they equal x do they become inverses. And why is that the case? Because whenever we do reflections, what do they have to reflect across? They have to reflect across what? Y equals x. So here's what I want us to do. Right now, before we shut this video down and you move on with the rest of your life. Alright? Let's type both these in. I'm going to do this one in blue, this one in green. Check it out. Okay. So in blue, I'm going to do x squared divided by 2 minus 6. I can do it this way because the calculator knows order of operations. And then over here in green, I'm going to do second x. Try that again. Second x squared, 2x plus 12. And I'm going to hit zoom, and I'm going to make it a square. Right, just remove. That does not look like an inverse. This is looking confusing to me. What did it say at the very beginning? It said x had to be what? Greater than or equal to 0. So watch this right. I'm going to go open parentheses, type in an x. So all of this right here, I'm going to set the domain, right? Divided by, open parentheses, x had to be greater than or equal to 0. Now I'm going to graph. Oh. Do you guys see how that works now? So this has a what? It has a restricted domain. Okay, this has a restricted domain. So here, where do your x values start? They start where? This one had to be started at 0. Where did the domain start over here? -1, -2, -3, -4, -6. So here your domain started at a -6. Here it had to start at a 0. So now, do they look like inverses? Hopefully your answer is yes, because that's what you do. All right, well, have a good day.